So let's begin our experiment. Like, alright, so where were we? Right, we just, as you can see here, we are actually in the node 0 and we pin center and also node 1, and you can see the package information is right here. And let's go to the tutorials. Right, and we can also start command as we did previously, and the difference is we are using this like a bash file that we use. As you can see right here, we are going to create a directory and release the resources. Yeah, we can use a swap exp command to swap out the experiments. Right, so next slide is the next slide is going to be using advanced type of no, it's like advanced usage of it. It's like to use other container types like embedded physical node or QEMU and OpenVD. Right, and this is like the valid options for us. And right, the way that we managed to do it is like to define what kind of container we want to use in the command that we used to create this experiment. Right, as you can see here, we are specify that we are using QEMU, and also here, as you can see, and right, this is the command that we used to do it. So this is like the command that we specify the type of containers right here. Everything is basically the same as previous command. We are using the same NIS2 file. Right, the next usage is we can mix the container types that we want to use by actually specify the container type for a specific node in the NIS2 file. As you can see right here, and this is like the NIS2 file. And so here, inside this for loop, we are trying to specify and trying to create all 9 different nodes as satellite nodes, and this command be here all the time in the every loop, and it specify the container type is QEMU for all those satellite nodes. Right, as you can see right here. Since we have already specified the node type in the NIS2 file, so we don't have to mention the container type in the command. Right, as you can see, we can mix. So for the node N8, we specify it to be embedded physical node. For others, they are QEMU. So this is how we mix 2 different container types right here. And let's go to the experiment. I'm not sure if I still have this. Nope. This one. Right. Let me modify the NS file. Okay, I just realized that the experiment that we are currently talking about is experiment 4, not experiment 2. So, I just opened the experiment 4. As you can see, we have 2 nodes because we have 2 physical nodes. So one is on the center, the other one is in 8. Right, so it's the same as tutorial. And we also have some constraints for different containers, as so you can check in the tutorials right here. And right, next stuff is mixed container constraints, and we can set in the open with a parameters using those two right here, using those two attributes, I'll say. So, two commands. You can see the first one is template. So this is all the available valid options, as you can see, different operating systems. And also the second one is open with the disk space. As you can see, it's like to setting the size of the file system of the container. We have gigabytes, megabytes, right, so we can specify 15 gigabytes for the file system. As you can see here, we can use this set attribute to set this attribute in the NS file, so we don't have to do it in the command line, and also we can do it separately. Let's go back to the slides. Next thing is setting the QEMU parameters. So we can do the URL, the load custom image, and also the arc. It's like the architecture of this VM. And also prefer QEMU users. We specify which user to mount. As you can see, it's like this. So as you can see in the command line that I use, the user is me, and this is like the project and the experiment IDs. This is like the valid options for architectures. Right, let's go back to the tutorials. Right, the next thing is change the packing factors. So we can change in the packing factors. As you can see, this is experiment number 1, and we are still using the same topologies, but we are trying to define like how many virtual nodes that to put on each virtual machines, right? So if we do 2, like from here, so you can see this is what I did right here. So like you changing the peg factors to 2 and still use the same topologies. This is like the result of the visualization results, as you can see right here. Right, so the next thing is the user packing. Experiment can specify their own packing using this continuous partition attribute. So you have to give a integer to it, and as you can see, this is like the descriptions. Right, next thing is multiple passes. So we are trying to use a larger topologies, as you can see it's right here. So check which one it is. Okay. This one? I'm not so sure. No, I don't think so. So this is our topologies. We have like 20 different sub networks, 3 sub networks, and each network with like 1 center and 20 satellites. But after this, we're going to pack the experiment using different like different factors. So this is like the first one. You can see 0 is one factor is 1. For the past one, you have like you have 20s, and this one 10, 5, and we are trying to specify. We are trying to specify all the parameters in the command line, and right. So after the picture is actually. Let me go to. Right, the way that we use to get the pictures, the picture of the topology is this command. So it could be different from what you see in the visualization part of the Ee542 Lab, but yeah, this is like a way to find the topologies right there, as you can see right here. So the line Y has going to be 3 partitions, like line 1, 6, 6, 7, 6, and line 2 is here, as you can see, 5, 4, 4, 4. Right, it's like 5 groups of 4, so it's 20. So we have like different kinds of partitions like this, and we specify the parameter in the command lines, and we get a picture of the topologies. So the reason why but sometimes we want more symmetric partitions. We are going to use node-only options, and this set all the cost of each architecture in the graph to 0. So the system of distribute those weights, which is Matthias, is going to ignore such arcs altogether, and so the partition is going to be even, like symmetric. And as you can see right here, I use these options, and the output result, this topology is going to be symmetric partitions. Right. As you can see, let's go back to the tutorials. Right, so we can use 2 options like size and path size to express like how many machines that we want to be used to hold in the containers. So size explains like how many like this one, how many machines to hold the whole experiment. So if we want to make multiple passes, so each is going to put into this parameters. Right, so let's go back. Right, so we are using path size options. For the previous one, it's not symmetric, because we didn't have this node only to let the matrix to ignore differences. And after adding this option to our command line, we have a symmetric distribution right here. Right. The cool stuff right here, we can mix the size and packing factors like this. As you can see, we use pass size and pass pack here, and this is like the command we use right here, 110 and 25 and 310 to specify nodes and packings size for the container. This is our result.